Hey y'all, today I'm going to be showing you how easy it is to get set up with SQLite in a new Go project. We're not going to use any third-party libraries, just two awesome command line tools. So to get started here, I've got a directory with just a Go mod and a main.go. If I go run main.go, you're going to see it's just a hello world program. And so we're going to be getting set up pretty quickly here with SQLite, as well as database migration files and code generation. It's going to turn our SQL queries that we write into Go code that we can then run in our application to query the database. So to get started, you're going to need two command line utilities. The first is dbmate, and the second is sqlc. So dbmate is a database migration tool that's going to let us easily create migration files and apply them to our database to form the schema. We can create a new migration file just by running dbmate new, and then we give it a name. So in this case, if we wanted to create a database for books, we would give it the create book table name. So now we run that command and we can look for it here. We see we got a folder, db, and then inside of it we have migrations and then our new migration file. In this migration file, we have a migrate up and a migrate down section. The migrate up section is to define the incremental change that we're going to make to our database. So we can go ahead and create that book table. Okay, so we've defined how we're going to create the book table here with an ID column, a title column, and an author column. Now we're going to go ahead and define how we can roll back that change. And if we're going to create a table with the migrate up, then we want to drop the table with the migrate down. So drop table book. Now that that's created, all we have to do is apply this. But first we need to tell dbmate where to find our database. So since we're using SQLite, SQLite databases are just a file in the file system. And so our location for the database is going to be a file, but if you're using something like Postgres or MySQL, it might instead be a URL to some remote location. Here I'm on the dbmate GitHub page, and we can scroll down to see connecting to the database, connecting to SQLite. And we see here we can define a database URL env variable. And in fact, we can actually just put all of these environment variables inside .env, and by default, dbmate will know to read from it when it runs. So let's go ahead and create a .env, and just paste that in there. That's going to create a SQLite database in db/database.sqlite3. Okay, so now that that's done, dbmate should know how to run and apply our migration. So we can go ahead and run dbmate up. And that's going to create the database if it doesn't already exist and apply all the migrations. So let's run dbmate up. We see that it applied the migration and created a new schema file. So let's go ahead and check that out. If we go to schema, we can see our new book table created, as well as a table for storing the migrations. Also, we get a database.sqlite file, which contains the database for our application. So now we can inspect the SQLite table if we like, just to see the columns, and we can see our ID, title, and author columns here in the book table. We can also see that there's a schema migrations table here that's storing each version, the hash associated with each migration that we've applied. We can also inspect the structure here. We can see that it's mostly right, although we would prefer not to have a nullable ID column. So let's actually roll back that migration and fix it up. So we can go back to our command line and run dbmate rollback, and it's going to roll back the schema. So now if we go to the schema, it's only got the schema migrations. Now if we refresh that table, that book table is gone, and the migration is unapplied. So now we can go back to our migration and we can fix our migrate up. So let's go ahead and say not null. Now we can do dbmate. We could do either new not new, dbmate up or dbmate migrate. That's going to apply the migration to the schema, and if we refresh, we see that that schema gets applied and that the structure now says that the ID column is not nullable. The next step is to start writing the queries that we're going to be using in our application. and we're going to be using a program called sqlc that will take those SQL queries and convert them into the Go code that is necessary to run those queries inside of our application. So the first thing that we're going to need to get up and running with sqlc is a YAML file to configure it. So let's go ahead and open that up, and then I'm just going to go to their website and copy their sort of getting started YAML file here. So we see there's a version, and then we are specifying, yep, SQLite as our engine. We're going to have some other options here. Firstly, I'm noticing that the Go code that we're generating is being sent to the tutorial package and tutorial folder. So I'm actually going to change that to, let's see, maybe something like query, because it's going to store all of our generated queries. And then here we're defining where we want to read the SQL queries and the SQL schema from. Here we actually want to do it inside this DB folder that we have, and then conveniently dbmate generates the schema that we can now use with sqlc to read in. So I'll go ahead and save this configuration, and now we're going to create that query file inside the DB folder. So let's go to DB, and let's go to query.sql. Defining a sqlc query is really easy. We just need a comment with the name of the query, and so let's do a create book query, and then the number of entities that it's going to return. So in this case, let's have it return one entity. So now this create book function that we're going to generate, we need to write the SQL code to create a book. So that's going to look like an insert into, and then we'll do a title and an author, and then the values. And here we're going to use question marks to specify where the arguments are. So this function create book that it'll create will have two arguments, one for title and one for author. And then finally, we want to actually return the book that we create, so we can use this returning star to return all the columns of the book table. We also might want a query for getting all books. So let's do name get all books. And then we can do many here. And then that's going to be a simple select star from books. Nope, book. So now that we've defined the queries, we can go ahead and run sqlc generate, and it will generate the code like we want it. So now if we go back in the file hierarchy here, we can see the query folder has a couple files in it now generated by sqlc. It has this db file here. This basically defines a wrapper struct around your database where you get access to all of the query methods that were generated. So we see here in the query.sql.go the create book function that we defined, and it was generated. It takes in a create book params struct, which just contains that title and author params from our SQL query. And then we have the get all books function as well that just takes in a context and returns a slice of books. Lastly, we have the models file that just basically maps each table to a struct with the appropriate columns and column types. So now that we've generated all this code, we can just call into it in our main application. So we can go to main, and first we're going to need to install the SQLite drivers, and then we can connect to the database and run these functions on our database. Here's the classic Go SQLite 3, and so let's look for, there's that. Let's run this. Boom. And we're going to import it, Go SQLite 3. And yeah, now we're off to the races. We can just start using SQLite 3. So let's import database.sql. And we're going to open the SQLite 3 database with, it's in the db/database.sqlite3 file. Is that right? Database.sqlite3. Yep. And then this is going to return a db and an error. And for the sake of demonstration, if there is an error, let's go ahead and panic. And then otherwise, we can construct our struct that is going to handle all the queries. And so from query, which is our package with all the sqlc queries, let's go ahead and new, pass in that db. That's just going to return, let's call it queries. This is the struct that contains all the functions for querying our database here. And so now we can start creating books. Let's do queries.create create book. This one takes 2 arguments, a context. So let's create a background context here. And now we can pass that into our function along with a create book params. So create book params. This one takes the title, right, as we defined in our SQL query. So let's do, okay, so I've got my book here, pragmatic programmer. Go ahead and insert that into the database. That's going to return, like we defined, a book and an error. And then again, we can panic there if there's an error. But otherwise, we can go ahead and print out the book that we created. And hopefully this should just all work, right? So not much code here. We don't have to, write all this SQL code to scan the rows in and write the query. So kind of abstracts away that low-level code, but you still get to write the SQL. So let's go ahead and go run main.go. And boom, we get a record there. It's got an ID, which is a good sign. The Pragmatic Programmer by David Thomas. So let's go ahead and check Table Plus now. And go to Data, refresh, boom, there's our book. It's got an ID, a title, and the author. So yeah, it's that easy to insert something into our database. So now, of course, too, if I wanted to go and insert another book here, and then we can, how about after this, just get all books. So now we want books error queries.get all books, and this one just takes a context. And again, let's go ahead and just copy this code. And if there's no errors, we can go ahead and just print out all the books. And here we aren't using this anymore. So now if we go ahead and run this code, we just get both of our books. And we see there it prints out a slice with the old book and our new refactoring book. And if we go back to Table Plus, refresh, there it is in the database. This, of course, didn't require any third-party libraries besides bringing in the SQLite drivers. We just used sqlc to generate some code and then dbmate to handle migrating our database. And these programs work really well together. The workflow is essentially to update your schema in dbmate and then create the queries that you want to create on the new table or on the new schema in general, and then generate the code and start calling into it. When I'm writing applications that query into databases, I personally prefer to write the SQL code myself as opposed to using some kind of third-party library like an ORM that's going to sort of abstract away the SQL. Something like sqlc allows you the flexibility of the sort of raw SQL code while also abstracting away a lot of the boilerplate that you would have to write without it. So that's about all there is to using sqlc and dbmate together. I'll go ahead and leave the links to those repositories in the description below. But otherwise, good luck to y'all. Please leave your questions in the comments. And yeah, thanks for watching. See you next time.